Okay, let us now do self-practice 11.4. In this example, you have three electrolytic cells connected in series. Okay, and a current is being passed through it for 20 minutes. Note that when the cells are connected in series, the same amount of current passes through each of the cell. Alright? So the question also tells us that platinum electrodes are being used. Okay, platinum electrodes are inert and they do not take part in the electrolysis process. Okay, and 0.21 grams of copper is deposited in the first cell, in cell 1. That should allow us to start off the calculation. Okay, so let us now attempt part A to find the mass of silver deposited in the second cell. Okay, so in part A, we need to find the mass of silver deposited in the second cell. Okay, in order to do so, right, we need to first of all look at what is going on in cell 1. Okay, at the cathode in cell 1, we have copper 2 plus reduced to copper. Okay, why are we looking at this? Because we have information that 0.21 grams of copper is deposited in the first cell. Okay, this will allow us to calculate the moles of copper deposited. Okay, by using the mass divided by its MR, and that is 3.31 times 10 to the power of minus 3 moles. Okay, with this, we are also able to find the number of moles of electrons that's passing through the whole circuit. Okay, so since the mole ratio between electrons and copper is 2:1, we can easily find the moles of electrons transferred by using 2 times the number of moles of copper formed. Okay, so that is 6.61 times 10 to the power of minus 3 moles. We can then use this information to link to cell 2 because for cells connected in series, it is the same amount of electrons passing through each of the cell. Okay, if we look at cell 2, we actually have Ag plus getting reduced to silver metal at the cathode. Alright, so the mole ratio between silver and electron is 1:1. In other words, it also means that okay, the mole of the silver deposited is equal to the mole of the electrons transferred, okay, which we have the value calculated earlier. So lastly, in order to get the mass of silver, all we have to do is to multiply this number of moles by the MR of silver. Okay, so 107.9. This will then give us 0.714 grams. Okay, so this is the mass of silver deposited in cell 2. Alright? Okay, we will now look at part B. Part B requires to find the volume of hydrogen liberated in a third cell, okay, at RTP, room temperature and pressure. So if you look at your diagram, in the third cell, we actually have H2SO4 aqueous as the electrolyte. So what's going to happen at the cathode is this. Okay, the hydrogen ions from the sulfuric acid will be reduced to form hydrogen gas. Alright, so how do we then go on to find the amount of hydrogen gas formed? Okay, keep in mind that earlier on we have found the moles of electrons transferred. Okay, so if you look at the ratio, the mole of electrons to the hydrogen gas is actually 2:1. Okay, so using this information, we will be able to calculate the number of moles of hydrogen gas formed. Okay, that's half the mole of electrons. Okay, giving us 3.31 times 10 to the power of minus 3 moles. Okay, so after we have the amount of hydrogen gas, to get the volume, all we have to do is to multiply this by the molar gas volume. Okay, that's 24 dm cube. Alright, that will give us 0.0794 dm cube as the answer. Okay, so in the last part, part C, we need to find the current passing through this cell. Okay, so recall that we have this equation Q equals to IT equals to NF. Okay, so what do we have now? We actually have calculated the mole of electrons earlier on. Okay, so that will be your 6.61 times 10 to the power of minus 3. F is the Faraday's constant at 96500. Okay, so I is the unknown and T, right, is the time in seconds. So we have 20 minutes, okay, changing it to seconds. Okay, with that, we are able to get the current I at 0.532 amperes, okay, to 3 SF.